Hey there, welcome to this week's video overview. This week we're going to be learning about L'Hopital's rule. We're going to be practicing increasing, decreasing, concave up, concave down intervals. And we're going to be solving word problems where we're asked to find an absolute max or absolute minimum. So the big idea here is, well, there are lots of different applications of derivatives. L'Hopital's rule is a very nifty way to simplify limits. Basically, we're going to categorize things into either a determinate limit or an indeterminate limit. A determinate limit means you plug in the number and it's really easy to figure out what the limit is. Indeterminate means when you plug in the number, you get some version of 0 divided by 0 or infinity divided by infinity or some algebraic equivalent version of that. So if you get one of these algebraic equivalent or indeterminate forms as they're known, then we can use L'Hopital's rule to simplify this thing quite dramatically. It's a very nifty way of finding limits that avoids all the messy tables and graphs and epsilon delta proofs and all kinds of stuff like that. For increasing, decreasing, concave up, concave down, this may seem as a review for many folks. It's a way of just understanding how things change, how they get bigger or smaller, and how they bend upwards or downwards. And lastly, the absolute max, absolute min word problems is something that is actually very relevant to almost every discipline that you apply calculus to. Humans are very interested in extremes. What's the most amount of money I can make? What's the fastest I can go? What's the least I can do and get away with, in terms of studying for that midterm coming up? All of these are optimization, right? How do I optimize something, get the most or the least out of something? And we're going to be using calculus, using derivatives to find absolute max, absolute min, which we've done before, but now we're going to be doing it using word problems. Okay, so what are the possible sticking points? Well, with L'Hopital's rule, oftentimes people forget to verify that it's in indeterminate form, so that's a tricky thing just to keep track of the steps involved for L'Hopital's rule. And for the optimization problems, the absolute max, absolute min, they are word problems. So we're going to have to make sure to go through the steps of the word problem solving process. Thank you. Where you identify the important information and you sort of illustrate it or create a table. So you organize that information. You include all of the variables and constants in your organized information in your chart or in your table. And you use calculus notation. You use, variables and constants, and you write derivatives as, d something, d something. We need to simplify these equations so that there's only two variables, one input variable, one output variable. And then we're going to go ahead and find absolute max, absolute min, which always occur either at a critical point or at an endpoint. We're going to make sure we answer the question, and we're going to check that our answer is reasonable. That is the problem-solving process. Anyway, so that's a stumbling block for some folks because they're just not comfortable with the problem-solving process, and more practice will help that. Okay, so some quick reminders. This week we don't have a lab assignment. We're just trying to finish up the assignments through 4-7, which will be the stuff for the midterm, which is not this week, but the following week. So we're going to try to finish up all the stuff and start preparing for the midterm. Please reach out. Let me know if there's anything I can help you with, if you have any questions, and I hope you have an enjoyable week.